Welcome to this tutorial video. In the previous episode, we created a text-to-speech interface. Today, we'll guide you through setting up the Large Language Model, or LLM, feature within Brick's AI functionalities. This allows the system to generate responses automatically based on user voice or text inputs. Such features can complete sentences, create marketing phrases, craft simple jokes, and even establish an interactive system to enhance efficiency. First, add a new application to the AI Toolkit workspace. Name this application Large Language Model AI. Enter the application and you will see an empty canvas. If you want to use AI-related features, make sure to go to the Settings button in the top right corner, go to Enable Unstable Features, and choose Yes. Some AI features are still in an unstable state but can support more testing and applications, so it's recommended that you enable them. Before we dive into the setup, let's briefly explore what LLM is and how it works. LLM is a technology designed for high-accuracy language generation based on contextual understanding. It analyzes user-provided input and generates text that is logical and contextually relevant, creating natural and coherent sentence continuations. LLMs excel in various tasks, including answering questions, drafting articles, summarizing texts, and completing creative writing tasks. The core concept of LLMs lies in completion, the ability to complete a sentence based on the user's initial input. For example, when a user inputs "Earth is," the LLM might generate a beautiful planet full of diverse landscapes and ecosystems, showcasing its ability to understand context and seamlessly continue the sentence. This capability stems from training on vast amounts of linguistic data, enabling the model to learn word associations, grammar rules, and contextual semantics for smooth language generation. On the Bricks platform, LLM provides two primary modes: text mode for generating single sentences and chat mode for advanced prompt settings and role definitions, supporting multi-turn conversations. This episode focuses on using text mode to help you master the basics of LLM operations. Before enabling the LLM functionality, we need to create a text input area where users can enter prompts to trigger LLM generation. First, add a background block to organize the input area visually and give it a structured appearance. Choose the rect brick and name it Prompt Input BG. Enter preview mode and adjust the design for a modern look by setting the background color to black and applying a border radius of 1. Next, within this background block, add a text input brick named Prompt Input. Set its appearance to have a white background, a border radius of 1, and a font size of 2. Adjust its absolute position to ensure a clean layout. Finally, add a raw input data outlet in the Outlet section, which will receive the user's input text and serve as the raw prompt for LLM generation. Once the input area is ready, we need to activate the LLM model integration. Add a generator component and name it LLM. The platform supports two types of models: LLM ONNX and LLM GGML. LLM ONNX is designed for high-performance devices or servers, making it ideal for scenarios requiring stable operations, such as cloud deployments or applications with ample computing resources, like large-scale server-side AI systems. In contrast, LLM GGML is optimized for edge devices and tailored for lightweight environments like iPads or iPhones. It operates without relying on high-performance servers, making it suitable for endpoint use cases. In this scenario, assuming a typical restaurant setup using lightweight devices like iPads, we will select the LLM GGML model to balance performance with hardware resource constraints. In the Properties panel, set Init to Yes to ensure the LLM model initializes automatically when the application launches. In the Model Settings, click the small icon next to the URL Custom field and search for Llama 3.23b. Avoid selecting models with names ending in -it or -instruct, as these are fine-tuned for specific instructions and may impact response coherence in text mode. Pay attention to the model size. iPads typically handle models up to 4 GB efficiently without performance issues. We recommend selecting the 2.16GB Llama model for its balance between performance and size, making it suitable for resource-constrained devices. You can explore various open-source models supported by the platform. Users are encouraged to experiment with different models and select the most suitable one based on specific needs. After selecting the model, set the completion parameters, change the mode to text, and link the prompt source to the raw input of prompt input so that the input text from the earlier setup becomes the prompt. To prevent overly long responses, add a new line and input a period to ensure the generation stops at the first occurrence of the designated stop word. After configuring the completion parameters, we need to set up the outlet area to display the LLM's operational status and generated results. These settings ensure that users can monitor the LLM's performance in real time. First, add a context state data outlet to show the current state of the LLM, such as loading during initialization or ready when the model is ready. Next, add an is evaluating data outlet to indicate whether the LLM is actively generating or processing, with output values of true or false. Finally, add a completion result data outlet to store and display the final output generated by the LLM based on the user's input prompt. Next, we need to add a button to trigger the LLM generation process. In the canvas, add an icon brick and name it Generate Prompt. Search and select the sparkle icon and set the button color to a vibrant neon purple to make it visually stand out. Go to the events area on the right side, edit the on-press event, create a new action, select Generator LLM as the target, and set the action to LLM completion run text completion. With this setup, whenever the user presses the button, the LLM will generate text based on the provided prompt and follow the configured parameters such as mode and stop symbols to produce highly relevant content. To help users intuitively understand the LLM's generated results and the current model status, we need to set up a dedicated display area. This includes a background block, a section for displaying results, and indicators for model and generation status. First, add a background block as the base for the results area to enhance the visual completeness of the output section. Add a rect brick named LLM Output BG, enlarge it to fit the lower section of the canvas, and set the background color to black with a border radius of 1 for a clean look. In this step, we need to create a dedicated area to display the generated results, simulating a conversational style. This includes an AI avatar icon, a dialog box style container, and a text field for the generated content. First, add an icon to represent the AI avatar, giving the interface a more intuitive and personalized touch. Add an icon brick named LLM icon, search for an AI-related icon, and set its color to neon pink to make it visually striking. Position it on the left side of the results area to simulate the position of an AI avatar. Next, add a dialog box style container to house the generated content. Add a rect brick named Generated Text Box. Set its border style to solid, set the border width to 0.2, apply a border radius of 1 and change color to neon pink. Place this box to the right of the icon to simulate a conversational layout. Finally, add a text field within the dialog box to display the generated results. Add a text brick named LLM Result. Place it inside the container, set the font color to white, and link the text field to the completion result of LLM to dynamically display the generated content. Adjust the font size to 2 for better readability. We also need an area to display the model's current status, such as loading, ready, or error, so users can easily understand its operational state. Add a text brick as the title for the status display and name it Model Status Title. Enter the text model status and set the font color to neon blue. Adjust the font size to 2 and position it above the dialog box. Next, add another text brick named LLM Status to show the actual model status. Link this field to the context state of LLM so the status updates dynamically based on the model's data. Use the same font color and size as the title to maintain visual consistency. To help users determine if the model is currently generating content, add a section to show the generation status. This will display true when the model is generating and false otherwise, making it easy for users to verify the process. Add a text brick as the title for this section and name it Generation Status Title. Enter the text generating and set the font color to orange. Adjust the font size to 2. Next, add another text brick named Generating Status to show the generation status. Link this field to the Is Evaluating of LLM so it dynamically displays the model's generation status. Keep the font styling consistent with the title for a cohesive design. After completing these steps, don't forget to save your progress in the top right corner. Finally, we will bind this feature to an actual device for testing. For example, if a restaurant needs to create promotional content, input a starting phrase like "each slice of our cheesecake," then press the Generate button. The LLM will complete the sentence, producing compelling promotional text to attract more customers and assist in creating creative marketing strategies efficiently. Congratulations on completing the setup for LLM text mode on Bricks. In the next episode, we'll explore chat mode, diving into prompt configurations and role settings to create more natural, personalized conversational experiences for various scenarios such as restaurant managers or customer support agents. Thank you for watching. See you next time.